Hello. For this video lecture, I will be discussing about the planes of weaknesses in rocks. Previously, we have learned about rock strength and failure criteria. As we have been introduced to the index properties of rocks, we learned na using laboratory techniques, possible na makitang effects ng stresses sa ating bato. As for this lecture, we will see how it shows in nature. So naturally, rocks and rock masses are heterogeneous, meaning they are quite often discontinuous. Merong naturally occurring planes of weakness that traverse along the rock mass. And yun yung mga nagse-separate sa kanila into perfectly fitted blocks. Furthermore, yung process ng excavation, it induces new fractures in the surrounding rock by virtue of stress readjustment. So for example, in underground mining, we make drifts and tunnels, di ba? Merong effect sa surrounding rock, yung paghukay ng mga empty spaces na yon kasi need maghanap ng outlet ng force from the weight of the rocks. Before we proceed, let me define two terms muna, discontinuities and fractures. Pag sinabing discontinuity, siya ang mechanical breaks in our rocks. If nag-road trip kayo, for example, tapos nakita nyo may isang outcrop of land and meron siyang layers. Example na yon ng discontinuity. After ng slide na ito, we will be discussing yung different examples pa ng discontinuities. We also have fractures, which mean macroscopic planar discontinuities. Note nyo yung word na macroscopic, meaning napapansin ng naked eye. Yun ang important sa ating mga BS Mining Engineering kasi ang information na yon ang dapat inonote pag nasa field. Later, we will know why these things are important. Merong classification si Palstrom ng different discontinuities. They span from being rock defects to joints and ultimately weakness zones. If papansinin nyo, ang nag-differentiate sa mga discontinuities natin ay ang length or span ng discontinuity. So it could range from 0.01 meters to 10,000 meters. Ang mga nakabox sa figure na yan, ang mga important terms na ipapakita as examples in the next slides. First is yung ating microcracks. They are defined as stress-sensitive tiny cracks caused by fluids. Diba, from the previous lecture or sa geology natin, we know na rocks are made up of different grains of minerals. So, nagsisip ang fluids sa grain boundaries ng mga minerals na yon, which causes the cracks in our rock. By the way, ang discontinuity is umbrella term for the definitions kanina. Fractures, if you recall, is macroscopic, pero ang microcracks for this instance ay microscopic. As makikita nyo sa scale na nasa image, it's in micrometers. Next is ang fissures. They are relatively small cracks. They are not that interesting kasi insignificant naman ang contribution nila towards safety. So, common silang nakikita sa field or even any other outcrop, pero hindi sila kasing laki ng following. Joints. Joints are relatively straight or parallel planar cracks observed in rock or outcrops due to extension or contraction. Ang joints na ay na-distinguish through the feature of no visible displacement or movement. Pero yun, they are still commonly confused with beds or bedding planes. Kasi usually, hindi naman mag-isa nag-appear ang joint. Minsan, there is this joint set. Pag sinabing joint set, joints that occur in group. Tapos, nakaparallel sila with each other. Meron ding tinatawag na joint system or the intersection of joint sets. For shear surfaces, discontinuity sila na medyo kamukha ng joint but are spaced more widely than joints. It could range from several millimeters as much as a meter kapag soft or friable yung rock. So, ganun kalaki yung displacement. Paano natin sila i-distinguish if kamukha sila ng joint? Besides sa yung ganitong features. This illustration shows yung difference ng formation nila. For joints, merong axial stress, tension for this case, which creates yung discontinuity natin. As for shear surfaces, na shear stresses ang nagkakos ng discontinuity. So yung feature for this case of a joint formed by tension, ganito yung magiging itsura niya sa left. Due to the tensile fracture, it opens. Yun yung nagiging discontinuity. It separates yung feature na nakita natin sa left side. Compared sa shear na nandito sa right, ang shear force ang nagkakos ng opening or discontinuity. So makikita niyo yung features displaced sila from each other. Faults naman ay yung large scale na discontinuities. They have recognizable displacement or offset. Obvious yung movement na nangyari. Very dangerous siya sa field kasi sure ang movement ng rock masses around these parts. Pero hindi may iwasan na may faults kapag nagmimina. Kasi many ore deposits lie on faults. Dahil sa damage na kukos ng fault, merong mineral-bearing fluid na pumapasok and yun yung nag-serve as ore deposit in the future as natutunan natin sa ating geology. So in essence, kapag meron kang discontinuity, the rock mass becomes weaker, more deformable, highly anisotropic. Bakit? Because there is reduced shear strength, higher permeability parallel to discontinuities, increased compressibility, as well as reduced tensile strength. Kasi nga, 'di ba? Separated na yung rock mass from another due to the discontinuity. So, by now, alam nyo na kung paano mag-identify ng ilang mga discontinuities visually. And by now, probably naisip nyo na ang significance ito ay with regards to safety sa ating mining. What is needed now is ang pag-document ng mga discontinuities para mahanapan natin sila ng solutions from the possible problems they would cause in the future. The good news is that it is rare to encounter a mass with truly random fracturing, meaning yung planar weakness, they usually cluster around one or more preferred orientations. So yung joint sets ay nag-appear sa isang area, ganon. So they are easily identified when the directions normal to the measured planes are plotted on a stereographic or equal area projection. So let us remember muna what stereographic projection means. If you can recall sa inyong geology, crystallography, and mineralography, there is this Wolf-Net and Schmidt-Net. Pag sinabing Wolf-Net, siya yung stereo-net na merong equal angle, while the Schmidt-Net, siya yung stereo-net na may equal area. Pag sinabing equal area, the parallels and meridians intersect at right angles. So this causes the angles to be equally spaced. Meanwhile, sa equal area, not necessarily intersecting at right angles, yung parallels at meridians, pero ang effect naman niya ay magkaka-equal area ang features mo. So sa application, ang Wolf-Net, it is used in crystallography, while ang Schmidt-Net, it's used in structural geology. Since ang Schmidt-Net ay nagpe-preserve ng area, mas ginagamit siya kapag nagpa-plot ng fold plunges, jointing, foliation, ayun, para makaproduce ng statistical analysis from the definitions. So how is stereographic projection formed? Recall nyo lang sa crystallography, yung upper hemisphere ang gamit, while in structural geology, sa projection sphere, itong lower hemisphere ang gamit. So there is this horizontal plane which represents yung surface natin. Meron kang, for example, geological feature na discontinuity represented by this dipping plane. So itong dipping plane ay magkakaroon ng intersection with the lower hemisphere. The intersection becomes a projection sa hemisphere natin. Yung projection na yon ay viewed from the top, not sa plane itself. Kasi kung sa plane itself, it will just become the circumference. So kaya viewed from the top, kaya magkakaroon ka ng isang great circle from the geological feature sa 2D na stereo net. So yan yung representation niya. So ito lang yung parts ng stereographic projection natin. Meron kang prime circle as their circumference with the poles sa north, sa south, and syempre meron kang equator with the east and the west. Ang great circle is defined as the meridians. Pag sinabing meridians, the lines from the north and the south. And meron kang small circles which describe the parallels or the lines from the east to the west or the horizontal lines. Of course, nakikita rin yung angles sa stereo net natin with Schmidt. North being 0, east being 90, and south 180, clockwise 270 hanggang mabalik sa 0. Yung gitnang great circle is the 90 degrees. Tapos from the sides ay 10, 20, 30, 40 hanggang pagitna. Ganun rin sa kabila. So the other features that can be derived from stereographic projection for this instance is lineation. Maliban sa discontinuities as planar geological features would provide, meron ding features used to describe linear formation. As we can see, pwede rin siyang i-plot sa ating stereographic projection. Isang application na pwede siyang paggamitan ay makikita sa example natin mamaya as poles. So ito ang practical application ng stereographic projections natin. We can convey information that describes geological features through our stereo-nets. So for example, meron kang top view ng pit. So ang geological features present ay potential wedge failures at potential plane failures. So ito sila, dahil meron siyang discontinuities, pwede mo silang i-plot into the stereo-nets para warn yung engineers mo of the impacts possible impacts nung discontinuities natin. So ito example ng isang highly fractured na rock mass. Pinapakita lang kung paano nagta-translate yung features or discontinuities sa ating stereo-net. This slide naman shows yung process ng pag-define or pag-document ng geological features natin. Supposedly, you would experience this in your structural geology class, but for now, we will be using these pictures. So, for example, meron kang outcrop, yung ginawa ng geologist ay naglagay siya ng compass to measure the strike and dip of that outcrop or that geological feature. Tapos, i-record yun sa notebook para later ay ma-plot sa isang stereo-net. So I will give a brief overview, however, of the features of interest na gagamitin sa ating stereo-nets. They can be divided into two if you have already noticed, the planar and the linear features. For the planes, we have these terms to describe them, the strike and the dip. The strike line of a plane is a non-plunging or horizontal line within a dipping plane or the intersection of a fault, bed, or other planar feature and a horizontal plane. Kumbaga, try to imagine the surface as a horizontal plane and the discontinuity or fault as another plane. Kapag pinag-intersect mo yung dalawang planes na yon, it forms the strike. Dip naman is the slope of the geological surface. So, meron siyang dalawang components, the dip direction. It's the compass direction towards which the plane slopes and the angle of dip or the angle that the plane makes with the horizontal plane. So, yung plane na nag-intersect kanina with the horizontal plane which made the strike, syempre yung plane na yon ay mag-dip, patuloy siya na pababa. Dito magagamit yung dip angle. I-measure niya kung gaano kalalim yung pag-dip nung plane na yon. And kung ang dip direction naman ay it's just 90 degrees from the strike. So perpendicular siya lagi sa strike. As for the linear features, we have these terms to describe them. The pitch, or sa USA, rake ang tawag, it's the angle measured in the plane between the strike line and the line of interest. So, meron kang line of interest, ito yung strike mo, that's a geological feature na gusto mong alamin kung gaano siya kalayo with respect to the strike. Yung line of interest na yon maaring mag-run along the dip. Yung plunge naman ay yung pangalawang term. It's used to describe the tilt of the lines, bale from the horizontal. So if ang pitch is from strike, ito naman ay from the horizontal. Pero just like the dip, meron siyang dalawang components. Yung angle of plunge or yung angle from the horizontal plane and the plane direction or also known as trend. Siya yung direction ng line natin. So, bakit important ulit yung pag-describe ng planes and lines as geological features? Kasi 'di ba sa example natin kanina, they are used to convey yung information of joints, faults. Para sa lines naman, crests, pati slick and side lineation, ganun. More importantly, yung poles ng ating discontinuities pwede i-describe as line para less nakakalito tingnan. Now that we have defined them, let's look at their notations or the way that they are described technically. For planes, ganito yung itsura ng notation, where D represents the cardinal direction and yung X ay numeral. So, pwede siyang i-describe actually in two notations, yung strike and dip, tsaka yung dip direction and dip for the planes. So, for example, given ka ng strike and dip reading na south 40 degrees east, 35 degrees northeast yung dip niya. Pwede mo siyang i-convert into 50-35. So, paano nangyari yon? Sa strike natin, nag-plus ka lang ng 90 since perpendicular naman lagi yung dip. Kaya, na-determine natin ang dip direction using azimuth reading from the north. And madederive mo yung value na to. 35 is just the dip angle. So, merong pangalawang example. You can pause the video now to try for yourself. And ganito yung magiging derivation niya. Derived na value, 360. For the line notation naman, simple lang. It's the trend and the plunge. Trend or plunge direction, yun yung other name niya. Puro numbers lang ang gagamitin since puro angles lang sila. So, ganun pa rin, X represents the numeral. And ganito yung example reading niya. With our topographical maps or geological maps, we can sometimes notice symbols with numbers. So, ganito lang ibig sabihin nila. They describe planar or linear features. For planar, ganito ang itsura ng bedding, ganito itsura ng inverted bedding, cleavage, axial surface, and then joint. For linear naman, meron kang strike and dip, and ganito, plunge and pitch. Now, we proceed on how to plot structures sa ating stereonets. Pwede tayong mag-plot by hand or using digital way. Kapag by hand, meron tayong syempre, tracing paper, and then we print out yung stereonets natin. For this case, we will be doing it by hand. So, assuming you have a stereonet and a tracing paper ready, ganito yung unang gawin nyo para ma-set up siya. Make a hole in the exact center of the stereonet by pushing the drawing pin through from the front of the stereonet. So, sa Schmidt net nyo, ang center, doon nyo itutusok yung pin nyo. And then, remove the pin and push it through the hole from the back. Para, kapag nilay nyo yung tracing paper nyo over that stereonet, we could freely rotate it with respect doon sa center ng ating Schmidt net. Kapag ganito na yung itsura niya, nandyan na yung pin, we could trace yung circumference or the great circle and then mark yung north, east, south, and west para pag ni-rotate natin siya mamaya, ay pwede natin siyang ibalik sa original position niya. So, for example, given ang ganitong reading and we want to plot a plane feature, 90 degrees east and 40 degrees south, paano siya gawin sa isang stereonet? Assuming na ready na yung previous steps, una, we locate the strike sa circumference or primitive circle natin. After, ay i-rotate natin yung point na yon to the north or the south, whichever is closer. And from there, we could start counting great circles for the dip angle. So for this case, 40. So we could count the great circles. Yung naka-bold na great circles, by the way, ay equal sa 10 degrees. So 10, 20, 30, 40. After nating identify yung great circle na yon, we should trace it and then return the primitive circle to its original position. Now, we have a plot for the plane feature na 90 degrees east and 40 degrees south. If nahirapan tayong sundan ng instructions or naguluhan tayo sa explanation, I have linked a resource sa description which shows the step-by-step plotting using physical materials. We can check it out for other techniques in plotting. As exercise, we could try plotting this in our stereo nets. I-pause nyo lang ang video if ayaw nyo mas point sa answer. So given ka ng north 32 degrees east and 20 degrees northwest na dip, ano ang maging itsura niya? Kapag na-plot nyo siya, dapat ganito yung magiging itsura niya. As for the line or linear features, ganito lang siya i-plot. First, locate the trend sa circumference. Given ng 225 degrees na trend, using azimuth reading, we can locate it over here. Pero this time, we rotate it to the east or the west. Depende kung saan mas malapit instead of the north and the south kanina. Kapag na-rotate na natin siya sa east and west, we could start counting great circles which correspond to the value of the plunge. For this case, 25. So 10, 20, and 5. Mark it and then return the primitive circle to its original position. And ayun, na-plot nyo na yung linear feature. So we could try these two examples out. Pause the video if ayaw nyo ma-spoil. Given ng 102 and 34, saka 230 and 12, ganito yung dapat magiging itsura nung pagka-plot nyo. So sa illustration na ito, ang sinasabi lang basically, on the stereo net, yung lineation is where the two great circles intersect. Notice how the bedding and the joint lie on the cleavage plane. So, medyo mahirap siya i-identify. Pero kapag pinlot natin siya sa stereo net, measuring the lineations on two different surfaces, una, syempre kailangan mo ng values, and then plotting them on the stereo net allows the cleavage to be defined. So, mas madaling makita yung cleavage sa stereo net compared if nasa field ka. So, di ba, pag nasa field ka, ang pwede mong gawin, measure from one side, another side, saka mo siya i-plot sa stereo net para makita mo kung ano yung parang itsura ng plane of weakness natin. Balikan lang natin yung point na ito kanina. So, it is rare to encounter a rock mass with truly random fracturing. Planar weakness cluster around one or more preferred orientations. Tapos, when they are plotted, they are easily identified. So, gusto kong bigyan ng emphasis dito is yung second line ng point na to. Meron tayong tinatawag na pole. Let us define muna what a pole is. A pole is the normal to the plane. In other words, it's a linear description ng ating planar feature natin. Possible pala na i-convert yung planar feature into a linear feature. Okay? Ganon yung pole. So, paano siya i-plot? Simple lang. Gawin lang natin yung first 3 steps ng strike and dip plotting. Pero instead of tracing the great circle, count a 90 degree separation from the dip. For this case, 20 degrees yung dip niya and nagbilang lang siya ng 90 degrees na amount ng great circle. After that, itong point na ito, siya ang mag-represent ng pole normal to the dip. And then, kapag na-mark nyo, pwede nyong ibalik sa original position niya and meron tayong plot for the pole of the dip. Okay? So, as you can see sa figure na ito, common na mag-occur in groups ang ating joints. Pero magulo siya tingnan and ma-effort pag naka-great circle. Mahirap makita ang grouping ng joints compared if naka-point siya or linear feature. Kaya natin ginagawa yung paghanap ng pole. Madaling i-group together kasi ang poles sa itsura nila dahil madaling may mag-identify ng group or joint sets given yung magkakalapit na points. Pag na-identify natin siya, alam na natin saan ibubuhos yung corresponding engineering na dapat gawin. As for the joint orientations, we have the following formulas which describe yung itsura ng pole natin. But first, let us define yung mga variables. L, M, and N are direction cosines. Pag sinabing direction cosines, it gives yung coordinates mo sa bawat axis. So, X axis is to the north, Y axis is to the west, Z axis is vertically upward. Upwards ang Z because the pole is nasa upper hemisphere as the depths are found in the lower hemisphere. Diba? Surface, depth, lower hemisphere. Corresponding pole is nasa upper hemisphere. Ang delta, by the way, is the angle from the horizontal plane pataas. And beta is from the north counterclockwise. So, kanina, balikan natin yung direction cosines. L is ganito yung formula, M is ganitong formula, and N is ganitong formula. So, for L, basically, siya lang yung x-axis na member. Bakit? Kasi, di ba, pag kinuha ang cosine ng pole na ito lang siya. And pag kinuha ang cosine ng line na ito lang siya. So, direction cosines is yung nagbibigay ng coordinates sa bawat axis. So, bakit natin sila kailangan hanapin? Magagamit natin ng L, M, and N sa pag-identify ng mean joint orientation given R na derivable rin with this formula using L, M, and N. Gusto natin malaman ng mean orientation para ma-identify natin saan ang focal point ng planes of weakness natin. 'Di ba? Kanina, nakita natin na merong focal point yung bawat grouping. So once na alam natin ang focal point, of course, kailangan rin natin hanapin yung angle and given lang tayo ng formula for the angle, which are these. Lastly, merong tinatawag na Fisher distribution or KF, which describes the dispersion of joint orientations with respect sa mean or focal point natin. Large KF means small dispersion, while small KF means more dispersed joints. So, ayun, N is yung number of joints, R yung magnitude ng resultant, P is yung probability na ang normal ay mag-make ng angle phi, degrees or less with the mean orientation, and phi, siyempre the standard deviation of the normal distribution. Ito lang yung formulas na ito, which is gagamitin nyo sa worksheet 9 ninyo. Ito lang yung references if gusto nyong magbasa further, pero basically yun na yung summary ng planes of weakness or lecture 9 natin. So thank you for listening.